Thank you very much, Don, and good morning, everyone. I'd like to start by saying we don't actually have too many slides because what we're talking about today is really more of a story than anything else. So this story is set in cyberspace, and the main character, right? So cyberspace in the 21st century, the main character is an elephant. Cyberspace actually lives this room is included in there. So this elephant was living in this room yesterday as well, right? And the elephant's first name is academic and the surname is misconduct. And the elephant goes by the nickname of cheating as well. Now, I don't know about other universities. This elephant, by the way, is a very shady character, but I've heard that other universities, their students are very trustworthy, right, and will not make friends, right, with this elephant. Will never do anything dodgy or shady with this elephant. Unfortunately, at Western Sydney University, we have a bit of a problem with our students making friends with this elephant a lot. And they like to sit exams together. With this elephant, they seem to think it's a lot more fun, social, and so forth. So we've had massive issues with this. This elephant, basically, there's sort of two parts. The body of the elephant is what I would call online cheating, and that's where we've had really major issues where. For example, one engineering maths subject that I coordinate, they were using online calculators to do one question in particular. We caught 30 students, right, doing that, right. Stephen is currently dealing with another engineering maths subject in summer school as our director of academic program, and has more cases than that of questions from exams being uploaded to check. And them writing the answers, right, to the extent of literally copying the answers directly from check, right, with different handwritings and so forth. So they're not even cheating very, very cleverly. So that's one problem which we're dealing with at the moment, which we haven't really found a solution for. But you might be wondering what all this has to do with the title of our talk, Numbers More Than Just an E-Assessment Program. Well, the elephant's trunk is the other part, right, of the academic misconduct cheating thing, which is really what we associated cheating with more pre-COVID and all of this hybrid or online teaching and learning that we've been doing, which is collusion, right, and copying. Really, this is where Numbers comes in as our hero, because we basically already seen yesterday briefly that you can use it to set questions with variables, multiple versions of questions, right, if you like, and well, not literally infinite, but almost infinite number of questions, and it has largely solved, right, our problem of the students working with each other, because they're doing different papers. The papers are unique to them, right? So what happened when we've done that? And by the way, I have to say that this is not really a talk about numbers. We won't delve into it great depths. Really, neither Stephen and I are experts at numbers, but we were forced to learn it. Certainly I was for my two subjects I coordinated in spring last year, with a very steep learning curve. Learn it very quickly so that we could run these assessments with multiple versions and so forth. It's more, as I said in the story, so more of a show and tell. And what we were thinking of is, are there other ways that we can use numbers? By the time we actually had done that, we knew that there were various ways that you could write questions in numbers, and we thought, this might be a teaching tool as well. And then Stephen had this idea. Right.
Okay, so I can skip this one. So problem that we were having, one problem we've had for quite some time actually, is that Western Sydney University decided to automatically record lectures. You had no control over it, they just did it. And that had certain consequences. lecture attendance declined, even if you added on the views. Maybe 50% lecture attendance, but I think now we're over 25, if not worse. And that's including online views. And so all calls a student engagement drop as well. Result, and failure rates were increased. And look, I think the majority of the students probably started off with the right intentions, but it's when you're, with your friends at the, having a coffee or, chatting, and it's like, oh, you lecture, it's time to go to lecture. Oh, you know what? It's recorded. I'll catch it up later. But of course, they never find that time to catch it up. I remember in the evaluations of teaching, we had one case where a student said, oh, there's way too many videos. It's too much. Because what they're trying to do it all during student day and go through all the lecture videos to understand the unit so they can do well on the exam. So they're just not doing it the way they should. Meanwhile, so already with these types of things, I thought we need to have something that's more engaging. I mean, these 2-hour block lectures are just ridiculous. Who wants to sit down and watch 2 hours of video? And I thought we've got to have something. I started playing with different ideas, but hadn't found anything super satisfying at that point. Meanwhile, there was a new problem. Well, maybe problem. Western Sydney introduced a new degree, a joint program with the University of New South Wales. So an engineering degree. And of course, that had consequences for us in mathematics because they had a whole heap of new service subjects they needed. So in particular, and the things we're going to be showing you today is this first one here, Mathematics for Engineers 1 Advanced, which covers, if I can't cover this video. But then there was all this lot as well, which so I'll be working on the next one next semester, and then you've got all my the second year subjects, something I have to teach. And we're going to do that all with no new staff. And we'll promise two new staff members, but that's never materialised. And we're already overworked. And so this is just kind of crazy. So, I mean, I guess the university kind of knew that. And so their solution was that we should just pre-record the lectures and not have face-to-face lectures at all. But we kind of knew that just wasn't going to work. So, and then seeing numbers, I felt that there was this opportunity. Typically used for testing and examination tool, giving questions to students. But with the lack of staff and the lack of student engagement in mind, and wanting a more interactive experience when students are learning, I thought about using numbers as a method to deliver the lecture notes. So interactive lecture notes using numbers has the following benefits. It allows students to try a problem right after seeing maybe some examples, or as soon as they've just gotten some new theory, they can try and see if they really got the concept or idea. So they get instant feedback, and that'll either build up their confidence. Oh yeah, I understand that. So I'm getting it right. Or it will, even if they get it wrong, it just signals to the student that, hey, I need to go back here, maybe read this again. What am I missing? Go over the lecture theory, or go over the example they may have just seen, and see what's going on, and then they can go and try it again. And then also, this is not really numbers, but on our view system, because the lecture notes now suddenly have got score points, I can put a kind of gatekeeper on it. And what I did is, I require that you must complete 75% of the exercises correctly. Correctly, 75%, or get that, score that 75% or more to get access to next week's lecture notes. And I kind of just wanted, a little bit of a push, a little pressure. You've got to keep up and do stuff, otherwise you're not going to get the content for the next week. And we can perhaps talk about how that works later. So, all right, so now let's show you. So what I'm going to I might just go into the site again. I'll go set up, and we'll go maybe to these calculus notes. So, all right, the student actually doesn't go through all these sessions because I'm going in as an instructor, but that's what they get when they click on. They will get the feed of what we're discussing this week, and they get all these sections. And I guess you see there's marks attached to it. I guess, yeah. So this week we were doing cocktails rules. You click on there, and you start getting a little theory. Explaining cocktails rule. Yeah, I guess essentially a proof there. You've got a situation where you can use it. And in this case, we've got an exercise straight up. I don't know if you want to talk about that.
Yeah. So the idea was that, of course, as Stephen said, we were all overworked. Stephen was the subject coordinator for this subject, right? But what we worked out we want to do with the way that we're doing this, it's not just your lecture notes and the exercises worked into it. There's also quizzes. We had weekly quizzes, and of course your tutorial exercises and solutions. So because I've had that experience of running numbers or assessments, at least in numbers, for both of my subjects the second semester last year, I ended up being the one to write the questions like these ones here. And the way it's all set up, by the way, in numbers, we may have time to sort of show you that a little bit later on, is you have a question statement, which I found for most of my assessments, you're not really using even that much, because where you get your different types of questions is actually the parts. Okay, so when you click on parts, there's then a bunch of choices, right? And this is one of them that I like, because we all know multiple choice questions. This is what in our old view system used to be called multiple answer. I think in numbers it's called choose several from a list. And what you can do with this is you give them a bunch of options where usually more than one of them is correct, but some of them are wrong, and the ones that are wrong are negatively marked. Okay, so if I look, for example, at this this question, right, and I like, by the way, to try with these type of questions to put it and a little bit of interpretation in there, so they're actually thinking more than just blindly, oh, okay, I'm doing a L'Hopital's rule question. I have to differentiate the top, differentiate the bottom, and then try to work out the limit. Okay. Students, in my experience, if you do that sort of thing, you give them a pile of questions like that, and then they'll try to do it with questions that don't work, because you're not getting the indeterminate form 0 over 0 or plus or minus infinity over plus or minus infinity, right? So this question, right, is designed that way to sort of say, well, look at it. You're not going to actually find the limits, right? But can you evaluate using L'Hopital's rule? And of course, you don't have to use L'Hopital's rule. That's why I carefully chose the words, which of them can be evaluated, right? And as I said, more than one of these answers may be correct, but you'll lose marks if you tick a box as correct when it isn't. So if we look at this first one, when we substitute x equals 2, yes, I'm getting 0 over 0, so that one's a tick. Same is true of the next one. The third one's infinity over infinity, that's going to work. The fourth one is not, because we've got 0 on the bottom, but not on the top. That one will be 0 over 0 as well, and this one won't be. So if I submit the part there, right, and scroll down, I'm hoping I've got 4 out of 4. Now what happens, and you can do this, by the way, you can set this up so they don't see what we see here, where the green lines indicate that they're correct, right? But Stephen was actually nice to them, right, and gave them an opportunity. Oh, I've got one wrong. Which one's right? And
I'll just put another one in.
Yeah, so I'll put another one. I'll untick this one and tick. Well, if I just leave it like that, oops, sorry. So it will tell me I've got 3 out of 4. Okay, so there's no negative marking because I've ticked 3 correct answers, but I've missed 1. Right. If on the other hand I tick one of the wrong ones, right, this is now going to change to 2 out of 4. I lost a mark for the wrong run on the bottom, right? Now, of course, when it is set up this way, students can actually cheat in the sense that they could just go, you know, tick, 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 all of them, oh, which ones are wrong, etc., and then just eliminate those, right? They would only be cheating themselves and most of the questions, and we'll see some other different types of questions that I said later on, they're actually not going to be able to do that. So they won't be able, just by being able to do it with this question, they won't be able to get anywhere near the 75% threshold to be able to get access to the next week's lecture notes. And as you probably noticed, I tend to like things out of 10, so I would like 2 or 3 questions in every one of these sections of notes, so that it would end up being a total of 10 marks. Very easy, therefore, for them to work out, whether they're getting 8 out of 10 for that section. Yes, the threshold for that one. We haven't yet done it, but we're thinking about doing it per section as well. Right, it's section separate. At the moment, it's just the whole week's lecture notes that they have to get 75% on to be able to move on to the next one. So Stephen, if you want to scroll down and talk about the rest of these notes,
I wasn't too fussed if they score the answers, because I think it's also just, it gives them information. Okay, that one's wrong. Why was that? And it makes them stop and think. So I'm thinking about the good student. I mean, yes, I know you can cheat, but I don't care. There's no marks attached to this. So I wasn't really worried about, the fact that the way I've set it up could be cheating. What have we got here? So then, okay, now we got some full examples. You applying the Hobbit's rule. And then another, it's just a graph. That one's probably, maybe that's okay. Some of them I think you might find a little bit too small or too big. I've learned now how to actually have full control over the size, and I need to go through it a little bit, do a few touch-ups there. I'll show you some nice diagrams later. I don't know, do you want to discuss this?
Yeah, so very briefly, a lot of the questions that I wrote ended up being fill in the blanks questions like this, where there's multiple types of blanks, right, that you could put in, right? A lot of cases, I'd make it very easy for students to make me numbers, right? Whether just integers or they can type in fractions as well. This one's actually both the A and B there, right? And this is sort of the best way I found to set it up, that limit as x approaches 0 of A over B. So A is going to be the derivative of the numerator, B will be the derivative of the denominator. So they're both functions, right? And you can do this in numbers. And by this point of the semester, this was week 10, right? They already knew when we wrote the initial questions, we were giving them instructions on how to type up, right, the expressions. So in the first one, right, it's going to be, 13. You can write x if you want of 13x plus 13. You can also write e to the power of brackets negative 13x. Okay, and I won't do the second one there. I'll just do this one. Do I have one too many brackets in there? Probably. So enter that, and it's right. Okay, but I didn't enter answer for B, or the answer for the limit. The limit, of course, will be a number, which I've told them they're the final blank fraction in its simplest form, which they should know how to type by now. Now, all of these numbers in here are variables. So one of the things we didn't say before is you scroll down, and I think it's probably at the bottom of these notes. I don't know if Stephen doesn't want to talk particularly about these. There's some more examples, I think, where you apply L'Hopital's rule more than once, although there's another pretty picture that Stephen put together. I don't know anything about how to get the diagrams and ticks in here. So Stephen was the one who was doing all the diagrams. Laura, did you have a question?
Yes, I see that they answer question for A and B.
Yep.
And so, for example, if they, let's say they had fraction and they multiplied the A you expected by 7 and the B you expected by 7 in Mobius, in numbers. So that means you can, what is in one box can depend on what's in another box.
Numbers will simplify fractions like that. So if it was 7 over 14, you type 7 over 14 instead of a half, I think it will still recognize that as a correct answer.
Well, you've got a choice. You can make it, if I remember correctly, you can force it to be in simplest form, and then you probably need to tell the student it needs to be in simplest form.
So what I mean is you could combine the answers in box A and box B into one thing. And that
Yes,
it's not,
you could. You could.
algorithms.
Yeah, no, you're absolutely right. Right, I was actually trying to be, we were really being, because it's the first incarnation of this, we were being very nice to the students. So I was breaking things up, probably into smaller bits than they needed to be broken up.
No, it's fine. It's just I
Yes.
was wondering if the boxes were independent. So it's great
No,
that you can do.
no, they're not. You can do exactly what you said. So that's
Except
absolutely true.
You can't, for fractions, you can't do that with functions. Like,
I think you can.
Really?
Yeah,
Yeah,
you can do it. You'll recognise the numbers.
numerically,
Yeah.
it'll recognise them.
Oh, okay, okay, yeah.
So you
fair
can
enough.
actually do it.
Yeah.
So what
Yeah.
I was doing is not absolutely necessary, as you say.
But I think, again, from a learning point of view, it's probably because if you got, you may have done one of the derivatives wrong, and at least
Yeah.
you know which one you got wrong.
Yes.
Yeah.
And you're not
Yeah.
big mystery which one is it.
Yeah, absolutely. So
So,
that's what
you know,
we were thinking
it's-
about as well.
It's not so much trying to, it is trying to be helpful or at least give feedback.
Yep.
To the students.
Now, if we scroll down, and these were ones, as I said, either infinity over infinity or negative infinities, or applying L'Hopital's rule multiple times, and then I had these questions at the bottom of this one, still blanks questions. This time we'll talk about a couple of other types of questions a little bit later on. But for example, in part B there, right, this limit can be evaluated by applying L'Hopital's rule how many times? Okay, so now again, students could guess, cheating themselves, but we're treating this as well. Okay, you want to really think about this properly, you're going to have to apply L'Hopital's rule the first time, and you substitute, you've got 0 over 0 there. And it turns out for this one, it's 3 times, right? And then if you've done it 3 times, you'll hopefully get the right answer. Okay. So the other thing I wanted to say was that when you get down to the bottom of this, you can see, try another question like this one, right? So because we've set this up with variables, if I click this one and tell me I'll lose all the answers from the previous part, okay, I don't care. We hope, of course, that the students, if they're engaged enough to be reading this, either because, oh, I better, otherwise I won't have access to the next week's notes, and then I'm behind with all the quizzes and all the other assessments, because they are a genuinely, engaged and motivated student, then they're getting questions with different numbers. You can see that all these numbers are different, right, to what I did before. And most of the time, my variability that I put in here was with numbers. You can have variable functions and so forth in there, but again, we were keeping this fairly simple on the first iteration of this subject. Okay, Stephen.
However, I would say they don't have to reset the questions if they got them wrong. They can still work with the ones they had. It's just that if a student wants to get extra practice and get another bank, set of questions. So yeah, once you finish the section, you just go back to the menu and then work through more things. So let me perhaps go to 10.4. So here we're talking about solving maximum minimum problems. So starting off in the lecture notes, just talking about basic advice on how to handle those types of problems, and then we start giving some examples. And of course, what I really like about attractive numbers too is that you can use LaTeX, and so that just the math looks beautiful. Let's get something interesting. Okay, so we're given one and a few extras. I don't know these, but then you've got you put nice diagrams with this. This one I kind of have memories of because the sea originally was purple apparently, but in LaTeX I told it to be blue, and in like a certain shade of blue. I mean, I mixed it with white. But apparently, a certain shade of blue and white, everyone else thinks it's purple. I don't see it, but I'm regularly colorblind. So I had other people say, "Hey, that's purple. What are you doing?" And it's like, "But okay." So
including your family, wasn't it?
Yeah, that's right.
Yeah,
they always had fun with me with colors, and because I just didn't believe. Come on, that has to be blue because LaTeX said it's blue. What I've done is mixed it with white. But so I had a lot more difficulty with that sea color. But yeah, and so you get with diagrams, with beautiful mathematics, and so you get, I think, a nice set of lecture notes. I guess the notes are unique to each student because of the exercise they've done.
Yeah, and then I mean the next ones again, rather than having them type in too many fractions, I would get them to do decimals with questions like this, which was not just find the area, the largest possible pig pen, so maximizing the area, but also the dimensions, right, of the shape, rectangular, and then, you know, slightly harder one with a church window, which the rectangle is surmounted by a semicircle, and so on. But the same type of question. So all of these ones were blanks as well. And the decimal thing is just, therefore, you can tell numbers to round to whatever degree of accuracy or precision that you want. So basically, I was doing it. Each blank is a decimal. I think in this first example, it was always going to be exact answers 0.5 or 0.3 or whatever. Whereas these ones, the second one, I said a decimal rounded to 3 decimal places. Okay. So if we want to move on to numbers itself. No, go back to the menu. Yeah. Right. So they were all calculus examples. If we go back to
so you want to go
algebra 1.
Might be hang on, I put my in. I want to oh, sorry. You know what? That's why I can't see it. Zoom in there's my way.
It's
so frustrating with Zoom.
Yeah, it does that. And so you want to go to the algebra at the top. No.
We want to go to week
9.
Week 9, week 5.
Week 9 first.
Oh, okay. I'll take the word for that.
And we were doing the algebra section.
Was going to be very good stuff here. There it is. Oh, that's right.
So basically, the calculus section was much chunkier. We based these on on some subjects that we already had in place, but the notes were not in LaTeX. So the process was lengthy. We would get somebody else generally to LaTeX up all the notes, right? Then when you put it into Numbers, most of it goes across, but some of the commands Numbers won't exactly recognize. So we then had to sort of tidy that up so it all sort of looked nice like this, right? Okay. And then, you know, after your explanation and so forth, the way, as I said, we were then interleaving the questions. This was all in the question statement, right? And then there would be parts, and it's a while until we get to the parts for this one, where they're doing exercises, which in this case is just finding a couple of cross products, 2 vectors, 6 components, 3 in each, worth half a mark each. So that one was worth 3 marks, with again all of these numbers being variables, right? Then I would get interpretation type questions again, which is based on the properties of the cross product. So what I did for this particular question was, here's 2 vectors, right? And again, if students are sort of serious, this is not really cheat proof, unless they want to do the whole random, let's just tick all of them and see which ones are right. We can get around this if we find that becomes a common problem, right? By just not showing them what the correct answers are, so which ones they've actually got wrong. And because these are different, they don't actually know what A, B, and C are, they don't know what the cross products are, right? Tell me whether these are true. So B cross A is going to be negative of A cross B, so that's this one, for example, and so on. We have to go through, I won't do all of this question. From memory, again, I think the last one down here was also, oh yes, so there's actually, this one was some applications of the cross products, and the last one is finding areas of parallelogram triangles and volume of a parallelepiped, right, and so on, the same sort of things. And look, again, right, back to our old friends AM, if they really want to cheat themselves, they can use online calculators to find the answers to these, right? But that's just about as time consuming as doing it yourself, and they really are cheating themselves, right? So by the way, I personally don't like AM because I'm allergic to mornings, right? Leanne will understand this as well. So thank you, Don, for checking us first thing in the morning. Yeah, thank you, Dan. Right. And the last one I wanted to, if we can go back to right now, the last type of question that I said.
I don't know if we've got time.
Well, this is the last thing, I think. So we'll probably do.
Okay.
Yeah. Was basically what they call match choices with answers, right? So this is, we go into, scroll up, that's all
I
right.
should roll my mouse.
Week learning modules, I think it was week 5. And this is basic, really, well, we give them slightly harder examples eventually, but these are all just the rules of differentiation. Yes, so the calculus one. So this was product rule question, I think. Yeah, there is.
That's going to stop.
It did, just in time. Okay, and Stephen, I know, doesn't particularly like the setting out of this because the spacing is not great. But the question when we scroll down, so we give them the product rule. In fact, in this subject, we actually proved it as well. And then the exercise, it wasn't this one, it must have been a later exercise there, match each function with its first derivative with respect to x. Okay, and I've written these functions again with variables in there so that they're sort of similar looking enough that you're not just going to be able to guess, right? Now you can, of course, go, Stephen did this exercise last night of going, all right, well, it's this one, this one, this one, and this one. Then you know down which one's correct. I think it was only, was none of them in this case. So that's great. And of course, if a student has any level of motivation at all, they're going to actually differentiate. They only need to do 3 of them, of course, and then they know the answer to the 4th one. Because of that way of cheating, and again, we could set it so they don't know which ones are wrong in here, right? Because of that, I didn't set too many questions like this, right? But there are some in there. And by the way, also, we don't have time to show any to you, but I was writing the quizzes as well. That was part of their assessment. A total of 10%, wasn't it? I think it's only 1% each week or something, right? So I'd write 5 questions in each quiz and be a bit more careful about the whole, cheat thing.
Just
so
settings.
Yeah, the settings and so forth, and so they weren't able to do any of this sort of thing. Okay, is that it? All right, so I think that this is probably a good place to stop. I'm going to go back to your slides.
It's question
It's question time now anyway.